This is the part 2 of the series of how to build your own promises library. Now in part 1, we built this promise function which worked for uh, which worked for a chain of functions which return the results directly. But if we try to return any promise within that chain of functions, it did not work. So let's in this video let's attempt to correct that. Uh, Now, as you can see, what was happening was if we made this higher order function add x return a promise instead of uh, uh, returning the result directly, and if we the run this code now, what we are getting is we are getting the result as a promise. So the implementation, what it should be doing, it should be evaluating any intermediary results. So if this is an intermediate result here, it should be evaluating this intermediate result to check if it's a promise instead of a result. So essentially what it should be doing is, so let's say it gets the result um, after resolving, after the client resolves it, it should it should check if it's a promise. Is it a promise? If it is, then what it should do is it should then invoke the promise and invoke the pipe function on that promise and supply the remaining functions in the functions array to that, and that returns a result. Now again it should check if the result is a promise. If it is, then invoke the pipe function on that promise, supply the remaining functions in the array of functions as input to the pipe, then get the result, and so on. Now essentially what we have to do is we have to check the result of a function in the pipeline, and if it's a promise we want to invoke the pipe function of the return promise, passing the remaining functions in the pipeline as functions parameter. What we want to do is we want to be able to break this reduce loop to invoke the pipe function of the return promise. So at this point we want to be able to say we want to be able to invoke x.pipe function and get access to the remaining functions, pass the array as remaining functions here. The problem with reduce function is we can't really break it, and we don't have access to the remaining functions that are there in the array. We don't have access to that. So we could use a for loop uh, to achieve this, but keeping in line with our functional programming approach, uh, let's see if we can do this using a recursive function. Now the way the functional programming languages work is generally they don't support loops directly. You have to have recursive functions to support loops. So let's get rid of the reduce and let's see how we can do this. Now we want to define a loop function. Now this loop function takes the obviously the functions, array of functions, and the result. Now we want to extract the first function in the array and the remaining functions. So we can use ES6 array destructing to do this. So what this feature of ES6 allows us to do is to get the first element of the array in and it will be assigned to f, and the remaining elements of the array are assigned to fs, which is what we want to do. Now if f is defined, which is, this acts like the stop condition. If f is not defined, what we want to do is we just want to return the result. If f is defined, we want to apply the function to the previous result, and we return the loop, which start applying the loop to the next set of functions, and we supply the result of the application of this function. So let's call this loop functions and r. Now this is still not going to resolve any of the, if any of the intermediate results are promises, it's still not going to give us the right result. But let's see if this compiles first, and it still returns the same result as earlier. Okay, there is an issue. Yeah, okay, I need to be passing the result here. Yep, so that works similar to the reduce function. Now that we are looping instead of using reduce, we should be able to stop this loop and invoke the pipe function on the intermediate result if it is a promise. So let's see how to do that. Now what we want to do is we want to first check if x is defined, and if x is defined, then is x a promise. We can do that by checking if x has a pipe function defined on it. Now if x has a pipe function defined on it, we want to invoke the pipe function. We have to supply the remaining functions to this. The remaining functions are there in fs now, so quite easy. We supply the fs, we supply the result until now, the intermediate result until now, which is x. We invoke it. If it's not a promise, we continue looping. Cool. So let us see if this works. Okay, we need to be returning this. For some reason it's not working as expected. Let's see why that is. We need to pass fs, loop fs, functions, result. It's because I have not resolved here. I was returning instead of resolving here, so this should be resolved. So yeah, let's see now if this works. Yep, that works. So it took 3 seconds to come back because the first second is to resolve this stage, and the next 2 seconds are to resolve the add 1 and add 2, and then it shows the result. So by logically applying our thinking, we were able to modify our pipe function to resolve any intermediary promises. Now the only thing that's remaining in this is the error handling part. Now let's introduce that. Okay, So we have the error handler here. Now what we need to do is we need to be passing the reject function as well. So let's add the reject function first. This is a reject function, and if this reject function is called, we want to call the error handler. That's pretty simple. Another thing that we can do is, maybe if the error handler is not set by the client function, we can set a default error handler. Throw new unhandled promise rejection. This is similar to the standard promises functionality. Cool. So we're passing the error handler. Now let's see, instead of resolving, let's reject it. Reject new error 1, error in ADX. Okay, so error handler is not a function yet. So that's because we are not passing the error handler here. So we need to be passing the error handler here as well. We missed that part. So let's see. Cool, so that works. Error occurred in error ADX. Now so it works if the promise is rejected in any chain, it's working fine, so that's all good. Let's go back to resolve. 12 plus x, front again, and that works. So that concludes our video. During a very succinct, by defining a very succinct function definition, we were able to pretty much define or get the functionality of a promises library. Of course, there are a few caveats to this. For example, we can't really add a catch clause in between of these. So that's one caveat. I think we can definitely extend this quite easily, but I like this interface because I think it's more cleaner. It takes an array of functions to apply, and then we have a error handler function. So we use some very nice features of ES6, like array destructing. We defined we did the loop in a recursive manner. We were able to use our intuition regarding how to resolve intermediate promises, and we were able to use this conditional expression to be able to do that as well. I hope you enjoyed the video as much as I did in coming up with this code. Thank you very much for watching.